Welcome to the Planet of Maths channel. In today's episode, we'll be solving inequalities with absolute value, and our first example is the absolute value of x and is less than 5. Such an example is solved in this way. First, we rewrite this inequality, so x is less than 5. We write this without the absolute value, but then we also need to add the same inequality sign on the other side as is here. We need to write it on this side. Further, we write our number 5, but with a minus. So it's like we're wrapping what was inside the absolute value, that x, we're wrapping it on one side with the number 5, just like here at the top. And on the other side, we add the same number only with a minus. Now we have a double inequality. We need to split it into two parts. The first part is this. We copy this inequality here. And on the other side, we take this piece and copy this inequality here. And we have two inequalities. X is greater than minus 5, and x is less than 5. Here along the way, an important word was said, the word and, which indicates to us that on the number line, we must mark the intersection of these two inequalities. But let's mark these inequalities in order. First, this inequality where x is greater than negative 5. We draw ourselves a number line. On this number line, we mark the number negative 5. And we mark all the x's that are greater than negative 5. Greater meaning the circle is open. And numbers greater than negative 5 will be on the right side of this negative 5. So here are the x's greater than negative 5 from this inequality. From the other inequality, we need to mark x's less than 5. So here we put the number 5. And x's less than this 5, again an open circle, x's less than this 5 will go to the left. And since this is to be intersection, then this is this piece. These are all the x's that are both greater than negative 5 and less than 5. We will write this same in interval notation that has parenthesis on both sides from negative 5 to 5. This is the solution to our inequality. Now example B, the absolute value of x is greater than or equal to 3. Here we proceed very similarly. First, we rewrite this inequality without the absolute value sign, meaning x is greater than or equal to 3. And then we rewrite this sign of inequality on the other side and add this number 3, but with a minus. It turned into a double inequality, and now we split this inequality into two parts. The first part is this piece, meaning x is greater than or equal to 3. And on the other side is that piece. So negative 3 is greater than or equal to x, and here, unlike the first inequality, we must put the or sign. The solution is this or that. We draw a number line, put the number negative 3 here, and put the number 3. And on this number line, we first mark this. Since the inequality is greater than or equal, the circle must be closed. And x's, meaning some numbers, should be less than or equal to negative 3. So starting from this minus 3, x's will go to the left. It is the piece. And now this inequality, x's, means some numbers, have to be greater than or equal to 3. Greater than or equal, so the circle is closed again. From this 3 we need to go, since x's are to be greater than or equal to this 3, then the greater numbers go towards the right. Thus, the result is this or this. So the solution in interval notation will be the union of two intervals. X belongs to the first interval from the left. It is the interval from negative infinity to negative 3. And on this side, the circle is closed. So we have to put bracket here. Union, the circle is closed again, so we have to put bracket here as well, starting from 3, and it goes on to plus infinity. With infinity, we always give parenthesis. These are exactly the two types of solving inequalities with absolute value. Either the absolute value of x is less than some number, then we have the intersection of the two intervals. It turns out to be just one interval. And in the second case, x is greater than or equal, this inequality sign is flipped the other way, then we get union of two intervals. It is either this or that. In such a situation, when the sharp part of the inequality sign is turned towards the absolute value, we get one interval. And then, when this sharp inequality sign is turned towards the number, not towards the absolute value, then we will end up with union of two intervals, to which values of x both inequalities are satisfied simultaneously. The first inequality looks like this. What do we do with it? We do the same as before. We rewrite that x is less than 5. But on the other side, we add the same inequality sign, and on this side we put minus 5. And actually in this case, we can already draw a number line. on this number line, we mark the number -5 and 5. And the solution here will be all x's, means some numbers, that are less than 5 and more than -5. Since we have such an inequality sign, we put two open circles here. And this is the piece. So here x belongs to the interval from -5 to 5. Our second inequality is x is greater than or equal to 3. So we rewrite it without the absolute value sign as x is greater than or equal to 3. We transfer this inequality sign to the other side, and here we place the number 3, but with a minus. And here, we can't deal with this as quickly as in the first case. We split it up into these two inequalities, meaning x is greater than or equal to 3, or x is less than or equal to -3. We mark this on the number line. On this number line, we mark the number -3 and we mark the number 3. X should be less than or equal to -3. Less than or equal, meaning a closed circle. Less than or equal, so we go left. Here the x's are smaller. So we have this inequality, and now this inequality, x, has to be greater than or equal to 3. So we draw a closed circle and go right from 3. Here x's are greater than 3, and the solution to this is the union of intervals, meaning x will range from -infinity to -3. Union, the interval from 3 to +infinity. And for now, we solved each of these inequalities separately. We need to draw everything on one picture. On the number line, we mark all the numbers, all 4 numbers that appeared here, starting from -5. Then it's -3, next is 3, and then 5. These are the 4 numbers. The solution will be the intersection of this solution and that solution. We mark the first solution, which is the range from -5 to 5. And the solution to this inequality is going from -3, here a closed circle, towards the left. And on this side, we start from 3, also a closed circle, but towards the right. And our final solution will be the intersection of this blue cap and these green caps. The intersection will include, first, this piece. It's located under both caps, and secondly, this piece. X will belong to the interval from -5. And here we put parenthesis. To -3, we put here the bracket. This is the intersection here on this side, union with the second interval, and this time it's going to be a bracket on this side, from 3 to 5. And here we put parenthesis. So x's from -5 to -3, and from 3 to 5 are x's that satisfy both this inequality and this inequality. Solve inequality. The absolute value of x is greater than 3, but less than or equal to 6. There's this double absolute value, we need to split it. We must separate this part first. It's going to be something like this. 3 is less than the absolute value of x. And on the other side, we need to take this piece, which means the absolute value of x is less than or equal to 6. Here we have two inequalities. We need to solve them and find the intersection of the two solutions. We need this and that. Solving this first inequality. I'll start by reversing this inequality in this way. The absolute value of x is greater than 3. It's just more comfortable for me to calculate this way. I don't know if it is more comfortable for you too. I just prefer to always have the absolute value on the left side, and it should be greater than 3. We solve it. First, we write x is greater than 3. So I'm rewriting it, but without the absolute value. And on the other side, I'm adding the number -3. This 3, but with a minus. In this case, when the absolute value is greater than something, here we can't take that shortcut. We need to separate it into two inequalities. The first inequality is x is greater than 3. Here is, or sign. And on the other side, we'll take this piece, so x is less than -3. This double inequality splits into these two, and we can already mark it on the number line. We mark the number -3 and the number 3. And let's start from the right side. X's are to be greater than 3, greater, not equal, so the circle is open, and off we go. X is greater than 3. Greater means towards the right. This is the first part of solving this inequality, and on the other side we have that x is less than -3. So, an open circle, and x is less than -3, looking from the x's perspective, so x less than -3 goes to the left side. And there, we have the solution to this inequality. Now we still need to find the solution to this one. So we do something like this. X is less than or equal to 6. So we transcribe this inequality dropping only this absolute value sign. But on the other side, we add the same inequality sign. We put the number 6, but with a minus. And this is the shorter way. Here we don't need to split it into such two cases, so we can already mark it directly on the number line. On the number line, we have numbers -6 and 6. The signs of inequality are either greater than or equal, so we close the circles. And x's are all the numbers between these two, so the cap goes here. And now we mark all of this on a single number line. We label the numbers that came out in the solution. The smallest of them is -6. Then there's number -3, next is number 3, and the number 6. First, we might mark this inequality. So it was supposed to be from -3 to the left. And from 3, we go to the right. This is the inequality. And now this. From -6, the circle closed. To 6, the circle closed again. We go up. And now we have this inequality transferred here. It's enough to write it all down using interval notation. Here we need to mark the intersection of blue and green. So it will be this piece here, and here. So the solution will be the union of intervals. X belongs firstly to this interval, that is from -6 to -3. Noting that at -6 there must be a bracket. At -3 we have to put parenthesis. Union. The second interval is from 3 to 6, where at 3 the circle was open, meaning we put parenthesis. And the circle was closed at 6, so here we put a bracket. The union of such intervals is the solution to our original inequality. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.